So this is the function r of x. They're asking for the domain. The domain are all the possible x values. So since this line is curved, or it's somewhat diagonal, it's going up and to the left, we'll assume it goes from negative infinity. So parentheses, negative infinity, comma, and then we want it, that's the smallest value possible. It's not really a value, we never reach it, but that's as small as we can go. And if you keep reading it from the right, we have all these negative values, except we get to 0, and 0 is not possible because of an asymptote. So we got to stop at 0. Parentheses means we don't quite reach 0. And then I think I need use u. Okay, so I can use capital U, I think. There's no symbol here. Oh, interval. There it is. So I'm going to use this symbol. I don't know if it'd mark it right or wrong with the other U. And then we're going to start at 0 with a parentheses. That means we don't actually touch 0. And then it goes to positive infinity. That's the domain. All values except for 0. What is the range? Those are all the possible y values. So negative infinity is as low as we can go. And then positive infinity is as high as we can go. Because there's no y values we miss. Negative 6 is possible. Negative 3. 0 is possible. So with this, negative infinity, infinity. Close those parentheses. What are the x-intercepts? So that's where it crosses the x-axis. It crosses at negative 8, negative 4, negative 2. Ordered pairs. Okay, so this is at negative 8 on the x, 0 on the y, comma, negative 4 on the x, 0 on the y, and then negative 2 on the x, 0 on the y. The zeros, those are the same as the x-intercepts, just not, they don't want points. These are all the places where the function equals 0. Negative 8, negative 4, negative 2. R equals R of negative 5, that means plug negative 5 in for x, see what you get out for y. So at negative 5 for x, the function graph touches at negative 3 for y. Negative 8 for x, we get out 0 for y. Is negative 4 positive, negative 0, so x equals negative 4. It looks like it's crossing the x-axis, so that'd be 0. How many times does line y equals 2 intersect r of x? So y equals 2, this is where y equals 2, and a horizontal line crosses twice, once here and once here. For what values does r of x equals negative 4? So this is the x values when y equals negative 4. So here's y equals negative 4. It looks like the x values are negative 1 and positive 1. So negative 1, negative 1, and positive 1. Give the intervals of x such that it's greater than 0. Okay, so we need to say all the numbers where the graph is greater than 0. So that's the smallest x values possible are negative infinity to negative 8 with parentheses. So negative infinity to negative 8, and then we need a union because it's also positive. The graph is above the x-axis. The y values are positive between negative 4 and negative 2. And then where it's negative, I'm sure, is the next one. Yeah, so where it's less than 0, so that's where the graph is negative. It's negative. It's negative y values between negative 8 and negative 4. Oh, sorry. Negative 8 and negative 4. Then we need a union. And then it's negative between negative 2 and that asymptote 0. And then we need a union because it's also below the x-axis between 0 and it looks like infinity. It looks like it's going to have a horizontal asymptote. So I'm going to say 0 is the next interval because x equals 0 is where this is below the y-axis, and then positive infinity. Oh, I did something wrong. Where does it equal negative? That's at negative 1. That's at positive 1. What's wrong with my answer? Where is x equal negative? Where's the function equal negative 4? R of x equals negative 4. So this is negative 4 for y. So that's definitely a negative 1. Oh, there's a third one. Sorry, I missed this one. Negative 6. There we go. That should do it.